All right, so I'm starting in camera. Okay, so what we're going to do today is we're basically just going to talk about design. Um, and so let's write here, design. Can people see my whiteboard? Can I write?
Yeah, I can.
Okay, good, good. Okay, good. So basically, in coding interviews and everything, even in real world software engineering, there's actually the concept of design, right? Where you want to build something. Give me a second. Or you want to build something, right? But before you build that thing, you need to sketch out how the thing is going to look like, right? You don't just start building. And even in building like real software, you have to, decide on the programming language you're going to use. You have to decide on what kind of database are you going to use. You have to decide on what kind of, front end framework you're going to use. You have to decide on, a whole lot of things, a whole lot of decisions you have to make before you build out, software. And so they want to, consider design at a, relatively, lower scale. And so in coding interviews and and other assessments, design can be broken down into two, right? That we are going to consider. The first one is the object-oriented programming design, and the second one is the system design. For system design, the system can be, a low-level thing or a higher-level thing. So we can even further classify this into, low-level, right, and higher-level design, right? So some people use LD and HD or anyhow you want it. But today we're going to focus more on the, the object-oriented design. But before that, I want to talk briefly about, these two. So for system design, right, we can choose any system we want. So by system, you mean you can think of something like software, something like, software related or some feature, So a typical one could be, let's say, YouTube, right? Like YouTube is a system. You can think of, Tiny URL. Some of you know Tiny URL. That website that allows you to compress your URL. The other ones like a type ahead feature, right? A type ahead feature. So for instance, if you're typing something on Netflix, you type, let's say, CORN, right? It can suggest maybe it's ELIUS. It can suggest maybe EL. It can suggest maybe ER, right? That's a type ahead system. Maybe want to design, there's a bunch of systems you can actually decide you can want to use. You can even decide to design a cache, right? You can decide to design maybe even a processor, right? There's a bunch of systems you can design. And some of these things, actually like real software. Some of them are just features, are just functionalities, right? Something like the type ahead one. So that's what we mean by systems. And hopefully on next 2 weeks or something, we're going into, into system design. We want to design an actual system and a bunch of things go into it, right? Like once you design YouTube, there's a lot of things you need to consider, right? We usually break those things into two, the functional components, right? And the non-functional components. Right. The functional components simply deals with, those things that affect the functionality of YouTube. So for instance, users should be able to stream, right? They should be able to watch their videos. They should be able to upload new videos. All those things are functional components. Non-functional components, right, of your system involves things like, is it reliable? Is it available, right? How does it, tolerate faults and all those kind of things. That's what we call the non-functional components. It doesn't really affect the functionality of the system, but it defines the system, right? And those are things we go into it a deeper level, hopefully in a month or so. And usually, a few companies for internships, a few companies ask, system design questions. So for instance, I know Netflix asked. So for Netflix, their second, technical interview, system design question. Last cycle, I got to design a type ahead system. Um, for new grad, a couple of companies also ask, including Netflix. I know Palantir also asked, and a couple of others. But then there's a second one which we're going to focus more on today. Let me change my color. That is the object-oriented programming one, where we are not really thinking about systems. We're thinking of to a small scale, maybe a data structure. Maybe it could even be, say, a functionality. It could be like kind of like something that looks like a system, but we don't want you to consider things like caches, like database or anything like that. We just want you to think about classes, about objects, about the interfaces. So to make all this more clearer, or what you got more clearly, let's actually use a very simple one. Let's say browser, a browser, a browser. Let's say one design a browser. Let's just call it system for now, or let me just call it a web browser. So want to design a web browser, and then we wanted to simply write, some implementation, for a web browser. And that is something, you have to do. So the interview can give you this simple question that, hey, I want to design, let's say, a web browser. But they could even tell, the history functionality of a web browser, right? So it could be like, okay, so we want to design the history the history functionality of a web browser. So that is, I can, go forward, right? And I can also go backward, just this functionality or something like that. And that's the question we're going to, focus on today. So when you get a question like this, the first thing you do is, you ask questions, right? Like clarifying questions. But hey, what features should my web browser support? So they could be like one, let's use a new page. Okay, so we're trying to create, a simple web browser here. And they're like, okay, so the functionalities it should support, right? Or basically the features, I want you should be able to visit, visit a URL, right? Visit URL. Number two, you're able to, go back, right? We're able to go back n steps, able to go back n steps, and maybe also able to go forward, right? Go forward n steps. Let's actually focus on these three things for now, sake of time. So we want you to design a web browser, and the web browsers like Chrome or Edge or or Firefox or something is very huge, right? But we just want you to focus on these three things, right, at a very low level, using the data structures and algorithms, right? How will your web browser support a visit URL? How will they support a go back n steps? How will they support a go forward n steps? Then interval will go forward. That point, it could even be you at the interviewer. They can tell that, okay, so for the visit functionality, we're going to give you, a certain URL, right, that we want you to visit. And then for the go back, we're going to give you, n, right? So maybe go back n steps. So assume you have, first visited this page, then you went to this page, then went to this page, went to this page. So you're currently here, right? Let's assume you're currently here. I want you to go back 2 steps. That means I want you to move to this place, right? I want you to simply move to this place. So that's the go back n steps. And then go forward n steps. Could also is also the similar thing. Let's assume you've come back n steps, so you're here, and I want you to go forward, 1 step, right? And that brings you here. So that is simply the functionalities we want you to support. Does the question make sense to everyone? Does the question make sense? Before we
It
move
makes
on.
sense to me.
Okay, if anyone has a question, please feel free to ask them chat. Okay, if you have any questions, just yeah. But this is basically how the problems look like. They give you, so usually these ones are methods, right? These ones are methods. So there's a method called visit URL, there's a method called go back, and there's a method called go forward. And your task is to implement, all these methods, to implement these functionalities. So when a person that should come to your head is a class, object-oriented programming, right? So the first thing you do is you write, for now, let's do this first. For now, we know you're going to here. That's a class name. And we know our class is going to have some methods, right? So let's write some methods. And what are those methods? Well, the methods we know now are a visit. We know system should do, right? What your thing should do. We know you can visit something. It can go back, right? It can go back, or you can just call it previous. Let's just use go back. It can go back. Then it can also go forward, right? So these are the methods we know. Now let's specify the arguments of those methods. So the visit, we're going to give it a URL that is a string. For now, let's even ignore the type. And then I'm actually doing it as I'll do it in an interview, right? So methods, visit takes a URL, then I'll just go to the URL, right? And then go back, I'm going to take n, that is how many steps I should go back. Then go forward also, I'm also going to take an n. Then a clarifying question can ask the interviewer is, hey, is it possible that going forward, the n that exceeds the number of pages we have? Then it'll be like, no, it will always be in range, right? It will always be in bound. That means that, so what I mean is, assume you're standing here, there's no way to ask you to go for it 20 times, right? Because the farthest you can go is just 1 step, right? So always to make sure that n is within bound, right? So this is what we have for the methods. And the next thing we usually define is what we call the attributes. Attributes are simply fields. In this question, maybe we use an attribute, maybe we won't, but let's assume we will. So an attribute, so let's actually split our attributes into 2 things. We can have class attributes. Class attributes. We can also have object or instance attributes. So let's briefly, touch on what these 2 things are. So I'm actually object-oriented programming, but just using a question, right? So class attributes are simply maintained across classes. So maintained is a yellow thing these 2 things. Let's change the color to something like black. So this is maintained across, all instances of the class. So let me show you what I mean. All instances of the class. So what that simply means is that assume I have a class A, right? And I create two instances of A. So this is my class A, right? And I create two instances of A. Let's say A1 is one instance of A, A2 is one instance of A, right? It's one instance of A. It's one instance of A. And then there's a class attribute called, let's say count, right? Count, count, That's what I mean, count. So in the definition, let's write here class A, there's a class attribute called count, right? And let's say I set it to 0, but each time I create an instance of A, I increase it by 1, right? So I can access, so I create, so let me just write it here. So def init, please follow me carefully, don't get lost here. I'm just showing you class attribute. Def init, let's make it cleaner. So def init, let's just write it init like this. Then self, I'm like each time it creates an instance, I want you to increase count by 1, right? By 1. So the first time that I created, so the first time, I don't want this. I want something like a highlighter. Okay, all right, let's just go with this. So the first time that I created, A1 here, right? Count is going to increase by 1, right? Count is going to be increased by 1. Then the next time I create count here, it's not going to continue from 0. Instead, it's going to continue from that 1, right? And count is going to increase by 2. So after here, A.count is going to be 1, and A.count here is going to be 2. So that's how class attributes work. Their feature, right? Their use can be propagated, what just happened, across, where's the undo thing? Okay, can propagate it across different instances of the class. Okay, let's go on to the next thing. Okay, wait, does that make sense? Class attributes. Class attributes. So we usually define them, right? We don't put them, we don't start the initialization inside the init. If you could see here, the class header, then we write them here, right? That's where we write the class attributes. If you've been reading code, you see it. But then the instance attributes, for the object attributes, we first like the init. So for instance, let's assume each time I'm creating a car, I want to give it the car a certain color, right? So I can pass color here. Right, let's see, C dot color, right, is equal to C. So when I was creating A1, I could like A1 is equal to A, then I'll pass red to it, then A2, A2 is equal to A, and I'll pass a blue to it, right? This is what we call an instance attribute. Now, an instance attribute, right, is bound to that object, is bound to that instance. So here, realize that the blue color is going to be for only car A2, right? Car A1 is going to be red, right? That's what instance attributes. So instance attributes affect that instance, right? And we typically, so that's why you see the self here. You see the self here. So those ones typically affect the instance which you're creating, and class attributes can propagate it across different instances. So now let's come back to our question. Wait, does this make sense before you go on? Does the concept of class and instance attribute make sense? I think it makes sense. I can actually send someone to do that on them. Okay. Now, let's go on to the next thing we want to talk about. Let's come up to the same one we want to design, right? So thinking of this system, right, we only want to create a certain browser, right? And everything that is going to happen is going to take place in that browser, right? So I can just stick with my instance attributes. Oops, why did I delete this? Wait, I wanted just a pencil. Okay, so everything can just be, an instance attribute, right? So with these things in mind, let's go on to design the system. I don't like creating new pages, so let me just erase these and let's go on. So let's see what we can do here. So you're just going to write a sample design. Let's clean this too, because we already have this here. So this thing we have here is what you can generally call an interface. This can basically be what you call an interface. So your interface simply, defines. So if you have an interview, right, you see, the cool thing about technical interviews is sometimes you don't even have to write code, right? You can, sketch out these things that look like code, they don't look like code or just normal English. And even if you don't get to write all the code, you can actually, go scot-free, right? So this is what we call the interface. So we can actually now start writing code. You're like, okay, we can write the class for our browser. So let's just call it browser, right? Please use very good naming conventions, right? Then we can start with our init function. Init, and I'm using Python because it's kind of more concise. Init. Then we can call self here, right? Self here. Then we can we can just do anything. For now, we're just going to use, a certain argument to tell us where we are, right? So we're just going to call it self.current, right? Self.current is going to be, let's say when each time we start our browser, there's a certain home page we have, right? A certain starting URL. So we're going to pass that starting URL to the browser when we're creating it. So let's just call it URL, right? Self.current is going to be URL. Does this make sense? So when you're creating the browser, right, or when you're starting the browser, when you open it, there's this homepage thing you see there, right? So you can even call it homepage or something. Anyone that makes you feel good. So just call it home, right? Then self.current, the current page is simply my homepage, right? That's simply my initialization. And then we can go on to implement those methods our browser wants to support, right? So you can just be like def, visit. This is the thing that tricks people. Please, if you're defining, methods, if you're defining methods inside, let me change the color. If you're defining methods inside a class, the two types of methods we generally use, right? So the methods also, so you see attributes, we said we can have class attributes and instance attributes. This is a similar thing for the methods, right? We basically can have, a method. The name is technically not a method, but it's just a method. We can have a class method and the actual is method. We can have a class method and an instance method. For an instance method, we write self here, right? We write self, then comma, then the argument it takes. For a class method, instead of self, we write CLS. I mean, that's a more common thing, I guess. It's just like a first argument is called, that's like for class, right? Then in Python, you put like at class method here, this decorator. But we don't need this for now, so let's just clean this. If anyone feels like they don't have a really solid understanding of object-oriented, programming in Python or some programming language, let us know. Then we can make a day to go through that. But for now, let's just focus on instance, right? Instance methods, right? Okay, so self, then the argument here, right? So visit. Now, someone will be like, why do we use self? Whenever you use self here, it means that when you're calling the method, you're going to have to call it on an instance of browser, an instance of the class. So for instance, if I create a browser like this, browser, let's say each time I call this, I go to techelevate.com, right? Like this, if you want to call the visit, this visit method, the only way to call it, you can see visit takes, so this is a signature for visit, is visit, then, then self, then URL. This self here, when we did methods, we explained that this self here becomes the first argument, right? And here, that first argument is browser B. But for method, you write the first argument first. So B dot, then the name of the method, right? Then the second argument, the rest follows, right? So if I want to visit, let's say g.com to be g.com like this, right? So that's what self does. So any method that has self, when you're calling it, you have to write the object name first. That is what the self stands for. Then dot, then the name of the method, parenthesis, then this follows. That's how methods work. Functions are different. For functions, we said about 3 months ago that for functions, you just write all the arguments straight away, right? Like you just write all the arguments here. But for methods, the first argument is written first, then dot, then the name, then the rest of the arguments. Does that make sense? I hope folks have not forgotten. Okay, let's move on. And it's the same thing even in Java and all the other programming languages, right? Like methods, basically you write the okay. So for visits, how are we going to do our visits? Well, for now, so you see, the cool thing about object-oriented programming is that they're actually testing your data structures and algorithms. So for now, let's just put 3 dots here. Then let's go to def. So that means we write something where we don't know what it is yet. We can also write pass. You have def go back. Then I'll go back, right? It's also going to, it's going to be called on an object, then it's going to be give us the number of steps. Def go forward. Right, that is also going to take self, then how many steps you want, right? And then we can even add like current, but for now, let's just leave that, right? So now the thing is, how do I to use? What kind of functionalities are you going to use? So now I want us to focus on the go back and go forward. Can anyone tell me what data structures they are thinking of, right, to simulate this functionality for a web browser? So let's just give a sketch here. So in an interview, you want to give a sketch or something, even like in real world. So assume you have, this where this is your home page, right? Then your browser allows you to go forward like this. Then let's say you come to let's say page 2, you come to page 1, right? Then you come to, let's say, page 3, sorry, this page 3, then page 4. Then the go back allows you to move from page 4, right? The go back allows you to move from page 4 and come back to, here, come back to page 3, even move from page 3 and come back to page 2, right? So what data structure do you think can be useful for implementing such a functionality? What data structure do you think will be useful? So think of all the data structures you know.
Stack.
Good. Yeah, we can actually use a stack tag. Assume I'm here, right? And I want to go back. We can even use arrays in a whole lot of other data structures, right? But stack is super efficient. Why? Because it's going to be what? It's going to be, what do you call it? Constant time, right? When you remove something from a stack, right? Because if we bunch of other things you can think of, but the stack is so good for this situation, because the last item that came in is simply the first item that was to go out, right? So stack is definitely the thing to use. But the next thing is, well, when I come back here, right? When I come back, I want us to do the go forward because we don't have time. And when I come back here to 2, the go forward allows me to also come back, to come forward, right? So what data structure are we going to need for that too? What data structure do we need for that? Because if I come from 4 to 2, I also want to be able to move from 2 and come forward. So we're not going back. The stack is going to help. What about it going forward?
Can I answer? Can I try?
Yeah, go ahead.
So for that one, I think linked list will do.
Okay, a linked list. So how are we going to use our linked list?
Pardon me?
So how are you going to use our linked list? Now note that it's the same system you're talking about. Like it's the same environment, right? So how are we going to use our linked list?
So we consider it consider the home 2, 3, 4 as node. Such that you can move each node, and you can move each node forward, and you can come back to, like you can reverse the node.
Okay, good stuff. Yeah, Dixon also added
hello.
He just said.
Yeah.
And it, right? So yeah, you can go ahead. Yeah.
Yeah.
So John said
so
yeah, go ahead. You can talk.
Yeah, I agree with him, the guy who said this linked list. But then for this case, doubly linked list will actually do a better work.
Job,
I think doubly linked list will do a better work since you'll be going forward and backwards.
Yeah, exactly. So now you realize that, right? When we first did our init, right? When we did our init, everything looked so good, right? But we get to a bit and we realize that no, we need more data structures, right? And then that will cause you to go back to your init and then change something there. So the interesting thing about these design questions is even before you start writing code, right, do some brainstorming, go through the functionalities, right, that you'll be supporting, right? Because when you go through this functionality, you'll be thinking, oh, you use data structure A. The second functionality, you're like, oops, I need maybe B, or I need maybe A and C, right? So before you start writing code, make sure you've gone through all those, all those functionalities to, narrow down the data structures you'll be supporting. So actually, we're going to use both of what Yuko said. So let's see something. So let's first consider the doubly linked list. I think that's a very, when I first solved this question, I actually used a doubly linked list. So let's assume we have these are pages, right? So as you said, actually, so let's actually, let's do it like from the start. So for the first page, for the home page, I want to create a node for it, right? Then when we visit, right, visit simply means, visit is like, hey, a new page has come. So that becomes our current page. So we move there, right? So if visits, right, and it's going to be a doubly linked list, right? So here the previous is none. You can set to be none for now. So if a new one comes, I'm just going to set, so this is page 1, our home page. If page 2 comes, I'm just going to do this, right? If page 3 comes, right, just going to put 3 to it, right? If page 4 comes, I'm just going to put here, right? And then this also points to none, right? Now, let's assume we're here now, we're on page 4. Let's assume that's where we are now. Let's assume we want to go back, let's say 2 steps. Go back, 2. It's simple our previous, right? You can see, because if it's singly linked list, right, you're going to get stuck. Because singly linked list, you can't go back, right? Because you can only go forward. But with doubly linked list, now, we can simply go back, right? Go back 2 steps. So we just use this, then we just use this, and then we are here, right? And it's simple, it's so done. You want to go forward again, let's assume now is go forward, let's say go forward 1, right? We can simply start here and then use the next point we are there. So doubly linked list perfectly does the job. But the stack solution is also super cool, right? Let's say we can use the stack solution. The stack solution, the thing with the stack solution is, normally it works for you go back, right? But then you go forward becomes an issue because when a stack is popping, it just pops the thing out. So let's see what I mean. Let's use the same thing. So this is our stack. We visited page 1. So we put page 1 in our stack. We visited page 2. Note, these are actually URLs, right? URL 1, URL 2, URL 3. We added this, URL 4, we added this, right? Then like go back 2 steps. So go back 2 steps, pop the things out. So it'd be like pop out, right? Then pop out again, right? Then you're like, oh, 2 is here. So then give us 2. Because for a stack, you can only, pick at the last item and you can only remove the last item, right? So then somebody would be like, actually, there's something else we could do, right? Instead of, okay, I mean, this worked, right? The go back worked. What about go forward? Go forward, everything is missing, right? We can't even find the first items. Everything is lost. All these items are gone. That is when the 2 stacks comes into play. Like, hey, when this stack is popping out the items, just store it in a different stack, and that's the solution. So let's see something we have here. So let's create another stack here. That starts out also empty. So each time we decide to go back, so when you take this 4, right? So this is stack 1, this is stack 2. When this one pops out, right, just push it here. So then this one will lose it. Then it pops out the 3, right? Then the 3 will come here, right? And then we can give you the 2. If I want to go forward, I can simply, just come here, right? You can literally empty, if I want to go forward like this, I don't know, it's better if we kind of make it this way. Let's make it this way 1. So it looks like buckets, pushing things inside buckets 2. And then, we have 4. Then we have 3. This is a clearer view. Let's look at this one. I don't know, this thing can't even enlarge. Okay. So let's say I want to go for it. So this is our stack 1. This is our stack 2. So let's say I want to go for it by 2 steps again. It's simple, right? 2 steps. It's simple. Just take this one, right? From this one. That'll move the 3. Put the 3 here, right? That'll bring the 3 here. So this will look something like this, right? And then you bring the 4 here. That will also look something like this. And then the top of the stack gives you the answer. So you can use a stack, but use 2 stacks, right? If you can use a linked list, just 1 linked list. So it all depends on you. Time complexity-wise, approximately the same, right? This one can be O of n, right? Assuming n is equal to, assume n is, n is equal to the length of the thing. I mean O of k, right? Where, you're going to move back, k times, right? Same thing for the stack. Each time you pop out of a stack, it's constant time. But you're going to pop k times, right? That gives you O of k, just like the same one. So time complexity is the same thing, but it's just your design decision, right? Whatever makes you feel good, right? They can be, they can give you another question, right? They can even add an extension, right? We're actually almost done. What is the previous thing? Okay, they can further tell you that, let's use the other one. They can further tell you that, hey, if I come to use a W linked list. Oh, space complexity, good. So space good. Okay, let's see the question. I saw the question. Read the question again. Okay. What if someone uses singly linked list but adds and pops at the head? Okay, so if you use a singly linked list work. Let's look at that. Give me a second. My pencil is misbehaving. Okay, so let's say we have a singly linked list like this. Okay, let's say none here. And I'm currently standing here. Right. If I want to go back, let's say I want to do go back. How can I do go back? You can't just pop. Like singly linked list, maybe I'm thinking Java or something. But like this are the formats, right? But you can't just pop because you're here. Singly linked list can only follow like this one forward, right? You can't just pop from it. Like if you pop, like what does popping? Is it the same as you're setting this node to none? If you set this node to none, how can I get here, right? Like singly linked list won't help you with the going back functionality. Unless when combine singly linked list with maybe what, like a stack or something, I don't even know how that's going to be done. So that gives you the issue. That's what I'm like. Or 2, you're going to decide on something, then you read the third one, and I think usually the last, like the right, that's going to like change your algorithm, your data structure overall. then we did go back. If I do visits, page 5. Page 5. Should page 5 come here? Should page 5 come? Sorry, my thing is misbehaving. Should page 5, can everyone see the? Should page 5 come here? Or page 5 should go to some new place from 2? Where should page 5 go to? Anyone? 2, or should follow 4? Your normal web browser, don't overthink it. Your normal web browser. If you do back, and it should go right after 2, right? I hope that makes sense. All right. Does that make sense? Does that make sense to everyone? Right? Because that's how it works,
Yeah,
right?
I didn't quite get it well.
Yeah. So let's assume that you've done visit, right? And then I want to see if there's a highlight where we are to visit, right, to page 5, right? So let's 5. Should 5 be, so it's a doubly linked list. It can also be a stack or anything, right? So if it were a stack, it would do something like this. Our stack would look something like this. 1, 2, this stack 1, and the other stack would be something like this, 4 and 3, right? And now 5 is coming. So the question is, where should 5 go to? That's basically the question we're asking right now. So we're like, okay, should 5, follow the last page that was ever visited, that is 4, as we can see here, or should the 5 follow node 2, where we are currently standing? Where should 5 go to? That's the question. So when you're doing your normal browsing, right, and you go back some page and you go to a new URL, do you think the web browser pushes the page, right, on top of the stack of where you are? Like, is it going to bring it here, right? Or is going to, let it continue at where you initially were? Where will it go to?
No, I think it should come after the 2.
Let me read the question again. Okay. What if someone uses singly linked list but adds and pops at the head? Okay, so if you use a singly linked list, right? So let's look at how singly linked lists work. Let's look at that. Give me a second. My pencil is behaving. Okay, so let's say we have a singly linked list like this. Okay, let's say none here. And I'm currently standing here. All right. If I want to go back, let's say I want to do go back, how can I do go back? You can't just pop. Like singly linked list, maybe I'm thinking Java or something, but like this is how the format is, right? But you can't just pop because you're here. Singly linked list can only follow like this one forward, right? You can't just pop from it. Like if you pop, like what does pop mean? Is it the same as, is it saying you're setting this node to none? You set this node to none, how can I get here, right? Like singly linked list wants to help you with the going back functionality. Unless one combines singly linked list with maybe what, like a stack or something, I don't even know how that's going to be done. So that gives you the issue. That's why I'm like, when you get the question, read all the methods, right? Read all the functionalities that your system should support and use that to make it. Because if you focus on just 1 or 2, you're going to decide on something, then you read the third one. And I think usually the last one is like the tricky one, right? That's going to change your algorithm and your data structure overall. And the last extension I want to add to this problem is assuming that they said, okay, so they're like, so here, this was visit. Here you visited the homepage. Actually, we can just do this init. Let's just do this one. So you init. There's the thing. This was init. That brought you here. Then you did visit, right? Then it did visit, right? Then it did visit, right? So that brought you here. Then we did, go back 2. Then we did go back 2 steps. So that's like we came here. Then we came here, right? Then the moment you get here and you do visit, so here I'm on, let's say, page 2, and I do visit, right? And I can do visit again. When I do visit, right, ideally in a web browser, somebody should tell me, if I do visit, let's say it creates this new node. Let's assume this is a new page. Let's call it page 5. Page 5. Should page 5 come here? Should page 5 come? Sorry, my thing is misbehaving. Should page 5, can everyone see the yellow color? Is it clear? Should page 5 come here? Or page 5 should go to some new place from 2? Where should page 5 go to? Anyone? Should it follow 2 or should follow 4? Your normal web browser, don't overthink it. Your normal web browser. If you do back, and it should go right after 2, right? I hope that makes sense. That's the same one I agree with John. Like it goes to after 2, right? Does that make sense? Does that make sense to everyone? Right? Because that's how it works, right?
Yeah, I didn't quite get it well. Could you go over it like small?
Okay, yeah. So let's assume that you've done visit, right? And then I want to see if there's a highlight kind of thing. Oh, there is. Can everyone see this highlighter? It's already in color. Let's see if we can make it a story.
Yeah, I can see.
So we did visits, visits, right? Then we had 4. Then we did 2 go backs. Then so we went back. So now we had no 2, right? That's where we are now, right? And then we do visits again. So when we do visits, we're currently still at node 2. That's where our current is. We're at node 2 now. When we do visits, right, to page 5, right? So let's say that's new URL 5. Should 5 be, so we're using a doubly linked list. It can also be a stack or anything, right? So if it were a stack, it would do something like this. Our stack would look something like this. 1, 2, this stack 1, another stack would be something like this, 4 and 3, right? And now 5 is coming. So the question is, where should 5 go to? That's basically the question we're asking right now. So we're like, okay, should 5, follow the last page that was ever visited, that is 4, as we can see here, or should a 5 follow node 2, where we are currently standing? Where should 5 go to? That's the question. So when you're doing your normal browsing, right, and you go back some page and you go to a new URL, do you think the web browser pushes the page, right, on top of the stack of where you are? Like, is it going to bring it here, right? Or is going to, let it continue at where you initially were? Where will it go to? So is it after 2 or after 4?
Okay. I think I get to know. I think it should come after the 2.
After the 2, right? Good. So that means after 2. Yeah. And that's the answer. It should actually come after 2. So that means that if I'm using a doubly linked list, right, after 2, the moment I do another visit, I'm going to delete all these things. I'm going to ignore all these linked lists after 2, the initial one, right? Because you can't go back to them. Like, you can't. Like, that's how it works. If I'm reaching a normal browser and you see, I know this may be a bit tricky, but that's how it works. So all these guys, these ones are going to be ignored, right? So that means that all the items here are going to be ignored. Other items here, because you can't go back to them, because now you've changed the branch, you've changed the direction, right? You've come here. Does that make sense? That's just in a simple. So if it were like a normal code, that could have simply been like self.current.next is equal to none, right? I just unlink it, right? So I unlink this, right? You can even just decide to do it straight away. So assume you created a new node. You created a new node with 5, right? With 5, that's a new URL. You simply do self.current.next. It's simply the new node, right? And then the new node, the previous is simply equal to self.current. That means you've actually linked them. You've done this new linking, right? So yeah, so this a bit about OOP design. There's actually a bunch of questions to actually see on this code and everything. This week, we're going to give a few problems to practice more. I like those questions because it's actually very challenging. There are some, trust me, you're going to combine data structures. There's some you're not even going to think about. Someone like diagrams are so pretty, right? That is mostly some of the things we do in real world. So I know some of you are thinking, when we say lead code, some of you are thinking, Dijkstra's algorithm, or this. Sometimes no, sometimes it's just like these things, right? We just want you to design systems. We just want you to apply the data structures right, to some of these things. If we go next month, we're actually going to these forms where we talk about an actual system like YouTube, like TinyURL, like Type-Ahead system, and so on and so forth. So give me a second. Okay. So we're going to use it's actually design browser history. So let's get a question called design browser history. We're going to use this question. Wait, can everyone see my screen? I've opened the LeetCode platform for the question we actually just looked at.
No, I can't see. I'm still seeing the white.
Yeah. Oh, you're still seeing the white thing. Okay, wait. Let me change the screen share. Screen. Start broadcast. Okay. Can you see my screen? Can you see the browser?
Yeah.
Okay. Let's set to Python 3. So this is the thing you're going to actually work on this week, and other things you can actually work on. So browser history, then actually it's same as the home page. They copied us. Okay. And then just solve this question and stuff. If I had logged into my LeetCode, well, let me log into the premium one and let's see. Even I've got a similar question like this actually 2 years ago when I interviewed with one company. It actually gave me a question like this. Let me see if I can quickly pull up some companies ask this question. What's the first name again? Design browser history. So my laptop is super slow. I need money to buy a new one. Okay, let's see. I'm opening to see. Okay, so yeah. So in the past 6 months, Roblox has answered 21 times, Amazon, Bloomberg, Apple. Like last year cycle, Oracle asked, Google asked, DoorDash asked, Microsoft asked. So it's a very, very.
I think we still seeing the design browser history.
Yeah, I opened it on my laptop.
Okay.
I'll have to sign in on this guy. Yeah, but it's a very it's a very important question. I think I can log in right now. My email, very long email and stuff. So that's it for today. We're going to share the questions. Please, if you didn't get anything, just rewatch it and we'll be good. If you think you don't have a good understanding of classes and objects in OOP, to let us know in the Slack workspace and see if we can schedule a quick session to just walk through those two. Okay, so that's it for today. And we are done. Anyone has any questions?
Yeah, I have a question.
Yeah, go ahead.
Yeah, so I want to find out if you can share some links like we can also watch generally on the object-oriented design.
Yeah, Zali. Yeah, we will share resources on that. Do you want to remind me? I get so swamped. Things escape me. When I get in old, like me, I'm aging quickly, so sometimes my brain forgets stuff. But yeah, do well to remind me in the Slack workspace, then tag me or tag any of the others, and then we will work on that and get back to you. It's very good. Like when you go work in the industry, like to build stuff, you don't write code using classes and objects and creating instances and doing that. Very few companies don't do that. Like companies that do functional programming, right? And even like let's say C, C doesn't have OOP, but OOP is like super good to know. So definitely remind us, and then we work on that. Right?
Yes, miss. Thank you.
Okay. Anyone else? Any other questions?
Yeah, hello.
Yeah.
With the linked list that we were working on, like I got confused. What if the case that maybe like when we were in the middle of the links, we decided to go to a different like link, and then we decided to change the current of the new node that we are creating to point to the ones that we ignored. Like
no, it's not possible. It's not possible. That's a functionality web browsers can support. Yeah, like if on try to web browser, if you go to A, B, C, D, and you come back to B, and you go to F, right? Like you've gone to a new path. Like you can't just you can't go back to D. You can try it on your browser and see. Actually, we can try it. Let's try it here. Let's share my screen and let's try again. Okay, let's simulate that. Wait, I'm starting my screen share again. Okay, can you see my screen?
Yeah.
Okay, so now we're going to go to a bunch of websites, right? Somebody should give me any website name. Any website name. Anyone that comes to your head. I beg, sanctify your minds. Don't give me some scary sites. Okay. What?
Chat.
I heard booking.com. Is it booking.com? Okay, so this is our website A. So website A, looks like now I have internet. So this is website A, right? So now let's visit another website. Let's go to website B. What website? Let's say cooking. Cooking too. Cooking is good. So we go to cooking. Then we go here, all right? So this is our website. So this C, right? So A was booking, B was the Google search page, right? And this is C, this page, right? Are we following? Then let's go to another website. Let's go to say GitHub, right? Okay, and this is D, right? So we have 4 websites now. Now let's hit back. Let's go back 2 steps. And that should take us the Google search page, right? So this is one back, right? And this is one back. This is the Google search page now, right? So this is where we are now currently, right? So now let's go to, and it's now about to branch, right? We've done back. Now I'm going to do visit again to some new website. Let's say jumping. I don't like to jump. Jumping Spider sounds cool, right? And now we've gone to Jumping Spider, and let's, maybe even hit Jumping Spider here to Wikipedia, right? So assume that now I want to go back to GitHub, right? Let's hit back. It won't take us to, it takes us to here. You hit back again, it takes us to this. We can go back to GitHub, like we are done. If we go forward again, it's going to take us to Spider, right? So you see, it's been discarded. That's GitHub, branch has been discarded. Does that make sense? Like now it's like a new path has been formed, right? A new path has been forged. And we can go back to github.com. Wait, Fred, do you see it? Can you see it?
Yeah,
hello.
I see it.
Yeah, that's how it works. Yeah. So it's like it discards the other ones and you can't actually go back to them. That's how web browsers actually work. So if you look at history, this GitHub, we can't even go back to him. Sorry, because a new path has been created. Those links have been discarded. That part of the link list has been discarded. And it's where Stack, the contents of Stack 2 have been discarded, right? We no longer use it. Okay. So yeah, okay. Time has gone over than I expected. Now if I try to cut it to 30, 40 minutes, it looks like I'm still Ghanaian. I don't stick to time. Of course I'm still Ghanaian. Okay, so let's meet God willing next week and let's see how far we can go. Please solve the problem. We will add a couple more. Some of you have done the design stack, all those questions are kind of this format, right? Always try to read all the methods before you start writing code. That'll really inform your data structures and stuff. Okay, see you all, God willing, next week. Bye. And those who recorded, please share the videos, share the recordings to us.
Thank you. Bye.
Mm-hmm.